One of the greatest events in amateur radio occurred in December 1921. In fact, it was a great event or breakthrough for all radio communication. It made the headlines of many newspapers and magazines such as the Scientific American. Amateur activity was resumed in late 1919 when the World War I ban was lifted. Most amateurs following the war were still using the crystal set type of receiver. And for the transmitter, they had the low-power spark coil type of transmitter. DXO maybe 10 or 15 miles under favorable conditions. By 1921, however, the advanced amateur was using tube-type receivers. Here is ARRL President Hiram Percy Maxim with a regenerative receiver at his home station 1AW. Let us have a closer look at a modern 1921 station. Here one can see the regenerative detector receiver with honeycomb coils and the 1 or 2 stages of audio. At the right is a long-wave monitoring receiver. Yes, the amateur used to listen to long-wave ship and shore stations since there were but very few broadcast stations in 1921. At the right foreground is the all-powerful 1,000-watt rotary gap spark transmitter. Average DX, 5 to 800 miles. What were the commercial stations using at this time? They either had spark or arc or a few low-power tube transmitters and possibly the newly developed Alexanderson alternator transmitter. The Rocky Point antenna system was to be a series of antennas in the form of a cartwheel. Each antenna would be 400 feet high and 1 mile in length, pointing to different parts of the world. This is a sketch of what one of them would have looked like. Other large commercial installations were still using the vertical type of antenna. This is a 900-foot one. It was agreed at this time, more or less by the engineers, that the longer the wavelength, the greater the distance. The short wavelengths supposedly had very little value. The multiple tune type of antenna required several tuning houses. And this is an Alexanderson alternator, a giant motor driving an unusually designed alternator whose output was in the radio frequency range. A masterpiece of the electromechanical engineering. These two alternators are each capable of 200 kilowatts of RF output. We've now seen what the amateur was like in 1921 and the equipment used by the commercial interests for transatlantic communication. The amateur had been allocated the low, inferior wavelength of 200 meters, while the commercials were given the long wavelengths up to 10,000 meters for DX. Now let us pause for a moment. The stage is now set for the 1921 tests. The radio amateur had always been fascinated with great DX, and spanning the Atlantic would be the ultimate. The ARRL initiated a series of tests in December 1921, when selected American amateurs would transmit predetermined code letters to be received, hopefully, by European amateurs. One of the leading stations in the tests was one operated by members of a New York City club, the Radio Club of America. One of their members volunteered the use of his station in nearby Greenwich, Connecticut. It was a small building with a 75-foot mast. And since they wanted to use a large flat-top type of antenna fed in the center, they moved the building over into the center of the field. Members of the club are all businessmen or radio engineers who took time off from their work to construct a new type of antenna and transmitter. It was group effort and everyone pitched in. And much to their dismay, it started to snow before they could finish the antenna. It consisted of 8 wires in a form of an 18-inch diameter cage. The vertical section was also a multi-wire cage. One of the leading participants was none other than Major Armstrong, the inventor of the superheterodyne and later FM. The antenna was commonly known as the T-type. One end was held by a new 100-foot mast, while the other by the original 75-foot pole at the edge of the lot. Both the vertical and horizontal sections radiated. The system worked against an elaborate radial system. Much credit must be given to these early amateurs for their use of such an efficient antenna. Their antenna could easily compete with any elaborate present-day 160-meter antenna. A close-up of the wires going into the radio shack. The vertical antenna feed is in the foreground, with the radials in the rear. And just a reminder, this entire system, including moving the building, erecting the 108-foot mast, was all done in a matter of a few days. A nice view of the completed station. And here are the 5 fellows who undertook the project. Left to right, we have Ernest Amy, John Grenan, a crack operator, George Burgard, Major Armstrong, and Minton Cronkite, who is the owner of the property and the holder of the station call that they used, 1 BCG. This is a general view of the transmitter. At lower right is the 2,000-volt ESCO motor generator set which provided the plate voltage. The antenna tuning system is at the upper left on the ceiling. Their objective, of course, was to tune for maximum current. They attained 6.5 amperes at 990 watts input. A single UV204 tube, which is a 250-watt oscillator, is driving 3 similar tubes in parallel as RF amplifier. They encountered great difficulty in stabilizing the circuit, since this was before neutralization, and the amplifier tended to oscillate. A greater problem was in keying. The only way they could prevent chirping and the amplifier from breaking into oscillation was to key the amplifier grid circuit and the oscillator simultaneously. Oscillator keying gave a chirpy note, so they mounted a 3-turn coil in the oscillator tank circuit. Note the relay K1 and K2. When the key was up, the amplifier was off, and the oscillator was on a different wavelength. When the key was down, the 3-turn coil was out of the circuit, and the oscillator was on the correct wavelength, and the grid circuit in the amplifier was connected. In other words, the oscillator remained on at all times. Rather tricky, isn't it? Here is a close-up. It was hurriedly assembled. Note there was no separation or shielding between the oscillator and amplifier circuits. And strange to believe, this could have been the most modern and the most powerful amateur transmitter in the country. And as you will see, it proved to be exactly that. This is a display in the AWA Museum showing the development of the UV204. It was the first high-power transmitting tube made in America. Developed during World War I, it was first called the P-tube. It was given the number 204 in 1921 and is the 3rd tube down from the top.